obviously, I've had to write an entire packaging infrastructure. I've had to, in my system, of course you could use package add and package rm if you wanted to. They're hidden well beneath, sort of, there's a user interface on top. Is how people should have done packaging. So things like upgrades. So for simple test machines that I can throw away, I use it quite extensively. Rolling it out into production and getting other people in the company to sort of maintain it sort of, maybe a bit of a challenge.
Tell us a bit more about the packaging. Surely it's quite a lot of effort to generate all these packages.
Actually, no.
Is it not?
No. I mean, so I have a shell script where it basically runs sort of uncompress, untar, cd into it, /configure, prefix equals user, make install, destier equals somewhere, go there, and then it's just standard SVR4 packaging. So package proto, fix that up so that all files don't end at O1B. Convert it into an SVR4 package. I actually do it slightly differently. Whoever invented package data stream ought to be strung up from a tree. So there's none of that. It's actually just the package, as you would on a file system, zipped up into an archive. So it's compressed, and it's very fast. And then, as I said, there's a little script that I've got that actually installs things, and it knows how to get them from off the network, and how to unpack them, how to install them, how to do dependencies. I don't rely on SVR4 packaging for any of that.
Okay, tell us about the dependencies in particular.
I ignore dependencies completely. Where do we go? Let's see. I don't use packaging dependencies at all. What I do is define, I call them overlays, but they're basically clusters of packages. And that, so you install that. It knows that, for instance, to install XFCE, it needs to install X11. And you make sure that this group of packages is correct. That it doesn't do dependency tracking at all.
So the dependencies are only between the clusters.
The dependencies are
a broad brush.
Yes. The dependencies are actually present in the packaging. So if you were to do things by hand the old-fashioned way, it would tell you, but nothing actually uses them. It's all done. And look, this is the thing. So you don't want to manage 1,000 packages. That would be stupid. You don't even want to think about a package. You just want to say, I want to do this. And off it goes. Clearly I've forgotten something. We spent a little time recently actually getting a graphical login working. It's in Xtremos at the moment, which is one of the other Solaris Vibe Indiana style derivatives. I haven't actually got it loaded onto this yet. It'll be in the next one. That's actually LightDM, which is the same that most of the Linux distributions are using as their desktop login manager now. And yes, working through all these sort of Linux-specific sort of coded that was an extent challenge. But yeah, packaging design is simple. The idea is that you can just do this for a moment. I've got to see the yes. it. Oh, yeah, I've got it grouped. Oh well. But no, you see that's the thing. You just say, install with this, and off it goes. Yeah, and, yes. Built OpenJDK for this as well. I was most impressed that OpenJDK 8 worked first time, especially given they completely changed the build system. It's now sort of a GNU Auto sort of thing, instead of these manual things. But basically, I just did the obvious thing, typed make, and ended up with Java 8 packages. Yeah, sort of. Doesn't usually happen. So, that's all the packaging is. Yes. Packaging ought to be simple. Yes. And Zap is a very small shell script.
Presumably the package add and so on are just the binaries, are they?
Yes.
I think source ever.
Oh no, source. The packaging tools were open sourced.
Oh, okay.
And they were put into OA. When they went to IPS, they put the packaging tools into ON basically to get rid of them and stop maintaining them. And so we get them for free.
The admin install consolidation didn't get opened up.
No. What was odd, of course, is that they open sourced the packaging tools, but not any of the patch stuff, despite the fact that they'd only written the patch stuff recently, and therefore knew where it came from, what all the licenses and rights associated with it were. Whereas with the SVR4 packaging tools, yes, God knows where some of the code for this came from.
Oh, it's 18.2.
I wouldn't like to sort of blame New Jersey for anything, but yes, there are certain things that you don't want to touch.
So how did you build the OS itself? I remember ON build or something from OpenSolaris days, but I can't remember ever using it successfully, I think.
This is actually a little bit of a Frankenstein. This actually comes from 3 places. I'm trying to cut that down a little bit. It's always going to come from multiple places. The OS itself is Illumos. That's a bog standard Illumos build. It's a few months old, this one. But it's basically absolutely standard Illumos build. You build Illumos, it populates the proto area, it then goes through the IPS manifest and creates you an IPS repository, which I then go through and convert into SVR4 packages. All the metadata is there. All the files are there. All the metadata about packaging is there. I've just got different names for packages. I do the same thing. There's a bunch of things like libxml2 and the like that aren't part of ON but are required to build the OS. And those are actually just packaged up directly off the build machine, which is actually an old Open Indiana box, which I need to need to do something about, at some point. But all the rest of it is just built by hand. I say it's just almost all this stuff is sort of standard GNU, configure, make, install, convert it to a package, drop it, you're done.
And how long does it take to do a complete build?
Well, OpenJDK takes about 2 hours in one build box. We put it up here, but my little build box is only a sort of 6-year-old Dell desktop. So the company's got lots of these. It's got hundreds of these. So if they break, you just toss it in the skip and get a new one out. They're reasonably good. And being reasonably old, so all the devices on them have actually supported, so everything just works. Well, I have got a brand new Dell desktop with sort of SSD in it. I need to sort of need to get some builds going on that. So it's things like OpenJDK that take it. But actually building the ISO, because I say you've got the Lumos build, you convert into packages. So building Lumos takes a few hours. I could probably rebuild the whole set of packages apart from the isolated big ones in sort of an hour or so. So most of them don't do a great deal. Actually, just once you've got this, you just copy the packages to the package area. You do run pretty much all the commands that I run, all the scripts that I run, I'll show. So actually, once you've got something assembled, it's only about 10 minutes to actually sort of go from here's a bunch of packages to here's a complete ISO. Probably just as well, really, because I mess it up far too often.
What if you wanted to fully automate it? There was the bit where you had booted off the RAM disk and then you had to log in as Jack and start running stuff, and then it asked a couple of questions. Automate all of that away?
I can automate all that away. And actually, the script's not there. There is a little bit of support there. The idea is that basically all you're doing is supplying command arguments.
Yes, I mean, you're running a shell script.
You're running a shell script.
Yeah.
So the idea is actually very simple, that sort of you set those, well, you supply a boot flag, so when you set install media, in fact it also understands install packages, so that if you boot off the network you can tell it where, where the packages are. Otherwise it'll actually, if it doesn't find them, it'll just go off to my repository, and therefore chew up bandwidth charges off my the colo, which is less than ideal. Yeah, you can tell it that. So the idea is I just tell it, have an extra flag so at the boot which says install profile equals something over here, and that just tells it what the device is. It'll do mirrors, for instance. Sort of you can mirror this onto sort of multiple devices if you've got sort of what devices you want to use, what software you want to install. And I haven't yet automated this, but it would be very simple to actually have this as something fairly late in the boot. Says, has this been defined? Find this boot property. Is it there? Right. Load that. Run it. So it's almost there. I don't think this version is right, but the next update that I'm running back in the office actually has this support in the script, so I can actually just feed it a very simple profile. And it's just like Jumpstart, only it's about this big rather than this big.
I like Jumpstart.
I still use Jumpstart. What also amazes me actually is the things like BEADM, which you'd think of were reasonably specific to OpenSolaris and IPS, and the like, just work exactly as you think. It's just that you just have to ignore all the package dependencies. When you install the BEADM suite, because it said, oh, I want IPS to be installed, I want this bit of Python, that bit of Python. So now carry on. The bits I've installed just work.
Great. Well, thanks very much, Peter. It's very interesting.